Good evening, everyone. I am Vaishnavi, and today we are gonna do non-preemptive algorithm. So, non-preemptive algorithm comes under priority scheduling. So, what is priority scheduling? So, a process scheduling algorithm is based on a priority where the scheduler selects tasks according to the priority. Now, in non-preemptive algorithm, CPU executes the process and it doesn't stop until the process is executed. Even if a higher priority process interrupts, it does not stop. Whereas in preemptive, when a higher priority process interrupts, the CPU forcefully stops and executes the one with the higher priority first. Now, let us do a problem to understand how non-preemptive algorithm works. So over here, we have the process P1, P2, P3, P4, and P5. And BT stands for buffer time. So buffer time for P1 is 10, 1, 2, 1, and 5. And priority is 3, 1, 4, 5, and 2. So let us draw a Gantt chart to understand how non-preemptive algorithm works. So we are going to start with the one which has the highest priority. So the smaller the number, higher the priority. Now P2 consists of 1. So P2 stands as the first priority that goes in here. And we are going to start with 0. And we're going to write down the buffer time number over here. Next, which the P5 has the second highest priority. So let us write down P5. And we are going to add the buffer time to the previous number's buffer time. So we have 5 plus 1, which is 6. Next, we're going to take P1. This stands to the next priority. And adding 10 plus 6, we have 16. And next we have P3. We are going to add 16 plus 2, which is 18. And last we have P4. We're going to add 1 to it, which gives us 19. Now, to understand whether the Gantt chart's calculation is correct or not, we can figure it out by adding the sum of all the buffer time. When we add the whole buffer time, we get 19, due to which we can say that our Gantt chart's calculation is correct. Next, we are going to find the turnaround time. So to calculate the turnaround time, we need completion time minus arrival time. Since we have not mentioned an arrival time, we are going to take this as 0. So P1 consists of 16, P2 consists of 1, P3 consists of 18, P4 consists of 19, and P5 consists of 6. Now I can tell this because of the Gantt chart given here. I have mentioned P1, which is 16 because 16 is here, and we have P2, which is 1, P3, which is 18, P4, which is 19, and P5, which is 6. So we have gotten the turnaround time. So next, let us calculate the waiting time. So how do we calculate the waiting time? So waiting time, we can usually calculate it by, so waiting time is calculated by subtracting the turnaround time minus the buffer time. So let us calculate the waiting time. So waiting time for P1 is 6, as it's mentioned here. P2 is 0. P3 is 16. P4 is 18. And P5 is 1. So for calculating the turnaround time, we can find how it works by adding the whole of it, and then we get 60, and we are going to divide it with the number of processes, which is 5. So we have 12 milliseconds. So after we calculated the waiting time, we have the sum of it, which is 41, and we're going to divide it with the number of processes, which is 5, which is giving us 8.2 milliseconds. That means it takes 8.2 seconds to wait and go on to the next one. So let's do another problem. In this problem, we are going to mention arrival time as well. So we have process, arrival time, buffer time, and priority. So in process, we have P1, P2, P3, P4, and P5. In arrival time, we have 0, 4, 7, 9, 12. Buffer time being 12, 7, 3, 3, 2. And priority we have 4, 3, 1, and double 2. Now, this could be a little different from the previous problem that we have done, because over here, even though we usually go with the number which has smaller number in priority, it has a higher priority. Since P1 is given 0 as the arrival time, we have to start with P1. So, starting with P1, let's draw a Gantt chart. P1's arrival time being 0, we are marking it 0, and the buffer time is 12. Now let's check out the next priority. So for the next one, we are going to go with P3 because P3 has 1, which means the higher the priority. So P3. Now we are going to add 3 to 12. So we have 15 as we're adding the buffer times. Now let's go to the next one. We have two numbers which have 2. That means two numbers which have same number as a priority. So how are we going to determine which which process enters the Gantt chart? So we're going to figure this out by FCFS. FCFS is first come, first serve. That means the priority process that comes first, it has a higher priority. So since P4 comes first, the priority goes to P4. So 15 plus 2, we have 18. And then we have P5, 18 plus 2, giving us 20. And last, we have P2, which is giving us 27. Now, let us calculate the completion time. So to calculate the completion time, we have CT. And for P1, we have 12. For P2, we have 27. P3, we have 15. P4, we have 18. And P5, we have 20. Now, to calculate the turnaround time, we are given the completion time and the arrival time. So the formula for this is completion time minus arrival time. So we have 12 minus 0, which is 12 for P1. And for P2, we have 27 minus 4, which is 23. And let's get a better view. So for P3, we have 15 minus 7, which is 8. P4, we have 18 minus 9, which is 9. And P5, we have 20 minus 12, which is 8. So thereby, we have figured out our turnaround time, our completion time. Now, we are left with waiting time. So to calculate the waiting time, I'm going to do it over here. waiting time. So the waiting time is calculated by turnaround time minus burst time. So I'm going to write the values directly. P1 is 0, P2 is 16, P3 we have 8 minus 3, which is 5, P4, which is 9 minus 3 equals to 6, and P5 we have 8 minus 2, which is equal to 6 again. So this is how we solve the non-preemptive algorithm problems. Thank you very much.